penuh bermisi Guru Ayu mencapai misi yang satu, bermisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okey, bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera semua. Saya Cikgu Rosemawati binti Zaini yang bertugas di SMK Bandar Bintulu Sarawak dari Akademi Youtuber bersiaran dari channel Cikgu Peh. Okey, sebelum kita mulakan kelas kita pada petang ini, lebih molek kiranya kita mulakan majlis ilmu kita dengan bacaan Ummul Kitab Al-Fatihah. Dan bagi yang bukan beragama Islam, bolehlah mulakan kelas kita ini dengan bacaan doa masing-masing, mengikut agama masing-masing. Okey, bismillahirrahmanirrahim. Amin amin ya rabbal alamin. Alhamdulillah, bersiaran kita sekali lagi dalam kelas tuition online Akademi Youtuber yang juga merupakan kerjasama e-didik Malaysia dan juga Kelab Guru Malaysia. Sebelum kita mulakan kelas kita, ingin saya ingatkan kepada semua pelajar dan penonton yang ingin menghantar komen, sila gunakan bahasa yang sopan dan gambar profil yang bersesuaian dengan tuntunan umum. Sila fokus pada isi pembelajaran yang akan disampaikan oleh Cikgu Peh. InsyaAllah semoga kelas kita ini dapat dimanfaatkan sepenuhnya oleh para pelajar. Ambil peluang ini, ikuti setiap kelas online percuma panitia Fizik menengah atas yang akan bersiaran pada setiap Jumaat pada 8.30 malam dan pada hari Ahad pada jam 3.30 petang. Baiklah, saya perkenalkan guru-guru yang berada bersama kita pada hari ini. Saya sebagai moderator dan control host pada hari ini, dan ingin saya perkenalkan presenter kita iaitu Cikgu Peh KH yang kini bertugas di SMK di Kolej Tingkatan 6 Tun Fatimah, Melaka. Okey, nanti beliau akan perkenalkan diri lebih detail lagi ya. Okey, juga diingatkan link sijil penyertaan akan diberikan di penghujung kelas ini. Sila ambil perhatian, link tersebut akan tamat dalam tempoh setengah jam selepas live. Hanya email e-didik, Jawi, MOE yang diterima. Okey, tanpa melengahkan masa, mari kita ikuti kelas fizik pada hari ini yang akan disampaikan oleh Cikgu Peh KH. Dengan segala hormatnya, dipersilakan.
Hello everyone. Okay, so good afternoon. So I am Mr.Peh. You can call me Mr.Peh KH, Cikgu Peh also. Okay, currently I'm teaching at College Tingkatan 6 Tun Fatimah, Melaka. And today we are going to learn new topic. Okay, so the topic is chapter 3, gravitation. So last week we have already finished our all subtopic in chapter 2. So the last subtopic for the previous lesson will be 2.8. Wet and will be a bit related to our chapter today, subtopic today. Okay, so in this lesson, so I'm going to discuss the first subtopic for chapter 3. So this will be 3.1, law of universal gravitation. So in this chapter, you are going to learn 3 subtopic. So 3.1 will be today's law of universal gravitation. So 3.2 will be Kepler law. And the last one, 3.3, will be regarding man-made satellite. Okay, so for your information, we have actually 2 classes, online tuition, PERCUMA for all of you. Okay, so the first lesson will be as per the Cikgu Yani introduced. So there will be the class tingkatan 5 Okay, so it's in Malay medium. So currently we at chapter 3 already. And also already discussed the first subtopic regarding arus and beza keupayaan. And the presenter is Cikgu Rosemawati. And for Form 4 class will be as usual. Okay, Sunday, 3:30 p.m. So will be in DLP, in English and Malay together. Okay, Malay language together. Okay, so before start the class, okay, so you can see the Cikgu Yani already shared the material for today's lesson. So you can just click at the chat room, okay, and then you will get the material for lesson today. Okay, so this is the Panitia Fizik KSSM Akademi Youtuber Malaysia. So today together with me, we have Cikgu Yani. So thank you, Cikgu Yani, for helping me today. Okay, so today's lesson, we have about 6 learning standards. So the first learning standard is regarding the explanation of the Newton universal law of gravitation. So you will be applying the formula, this formula, F equal to G m1 m2 over r squared. Okay, so I will teach you the easier way how you remember the definition for Newton universal law of gravitation. Okay, so before we go to the law of universal gravitation, okay, so this is the term universal force you need to understand. Okay, so from the previous subtopic 2.8, you have already learned the definition for gravitational force. Okay, so the gravitational force will be the force that added on the object due to gravity. And then here, gravity can be defined as the force attraction between two objects with mass. Okay, so which is related to the weight and also the law of universal gravitation. Okay, so here you can see that the universal force is a gravitational force that act between two body in universe. Okay, just like the figure here. So we have two planets. The gravitational force is adding between these two objects. Okay, so and then you can imagine the gravitational force adding between the apple and the earth. So from the what we saw, okay, in this GIF, you can see the apple is dropped from the tree due to the attraction of the gravity towards the center of gravity. But actually, there is a pair of the gravitational force which is added between these two objects, the earth and an apple. Okay, so the gravitational force exists in pair with same magnitude. So that means here, F1 and F2, which is the pair of the gravitational force applied in these two objects, earth and the apple, is actually the same. However, we just can see the apple is dropped or attracted towards the earth to the ground, right? But we cannot see the earth or the floor moving up towards the apple. Okay, so this is due to the mass of the earth is greater than the mass of the apple. So we can just see the apple accelerate towards the earth. Okay, so now we go to the Newton's universal law of gravitation. Okay, so per the statement here, okay, so we can explain the law as gravitational force between two objects is directly proportional to the product of the masses of the both objects and inversely proportional to the square of the distance between them. Okay, so you can see the statement is very wrong. Okay, so how we can memorize this statement? Okay, so here you can see the first sentence, the gravitational force added is directly proportional to the product of masses of the both objects. So the object here, the mass will be M1 and M2. So will be first relationship between the force and the mass. Then the second, you can see the relationship here will be the second part of the law here. So which is inversely proportional to the square of the distance between them. Okay, so you can memorize these two relationship where F to the mass and where the force to the distance. And we combine, they will become like this. F directly proportional to product masses and inversely to the square of the distance between these two objects. Okay, so here we have a constant at the final equation, which is F equal to G M1 M2 over R squared. So the F is the gravitational force between these two objects. So we'll be referring to F1 and F2 here. Okay, and F1 and F2 will be equal. Okay, as per explanation in the previous slide. Okay. Okay, so the universal gravitation constant will be stated at G, and the value will be fixed, which is equal to 6.67 times 10 power 11 Newton meter square per kg square. Okay, so how we can get this unit? So we come from the equation where F equal to G M1 M2 over R square. So we rearrange. So we'll get G will be equal to F R square over M1 M2. So the unit for force will be Newton, and then the R will be distance will be meter square, and M1 M2 will be kg times kg, become kg square. So NR we get the unit for the G will be N meter square kg per kg power negative 2 here lah. Okay, so the M1 referring to the mass of the object 1 will be the blue color object here, and then the M2 will be the mass of the object, second object will be the green color object here. And the distance will be measured from the center to center of the object. Okay, so this is what you need to highlight here. So the distance is measured from center of the object. Okay. Okay, so this is very simple. For the standard learning standard 1, you need to memorize the definition and the equation. Okay. Okay, so we go to our learning standard 2, which is the problem solving involving Newton universal law of gravitation. So that means you need to apply the formula F equal to G M1 M2 over R squared in 4 different situations. So the first situation here will be the two static objects on the earth. Okay, so for example, the apple and the orange is on the table. So both of the object is actually have a pair of the attraction added between them. Okay, then the second object on the earth surface. Third will be the application between the earth and the satellite. So you can look at the figure here. Then the fourth will be the earth and the sun. Okay, so all of these 4 situations will be using only one formula in the discussion in learning standard 2 here. So here I'm using 2 trial questions to let you know how to solve the problem involving Newton universal law of gravitation. Okay, so the first question here will be the trial from Malacca State 2022, question number 7. Okay, so the question is like this. So diagram show the moon that orbiting the earth. So be here. So the earth, the moon is orbiting the earth. So determine the force exerted by the earth on the moon. So we want to get the force here. So the force is actually pairing according to the law of universal gravitation here. Just now we explained. Okay, so the question given the information about the Earth mass, which is with this value. So the Earth mass will be normally of the question. Okay, and then the Moon mass will be given by the question and not stated at the first page of the formula sheet. Okay, and the distance between the Earth and the Moon is given also in this question. Okay, then G is given. So the G value and the mass of the Earth will be given at the formula list at the front page of the question normally. Okay. Okay, so here the question actually give all information already, including the R here. So will be this value 3.83 times 10 power 8. Okay, so we're applying the formula we learned just now. Okay, so here the R is given already with this value. Okay, we just substitute. Okay, so some of the situation the question is given. Okay, for example, here is Earth. Then the question just given the distance between object to the surface of the Earth. Then you need to add on the radius of the Earth. And normally we give the symbol H for the distance between surface of the Earth and the object. So R will be equal to letter R lah. Okay, small letter R will be equal to radius of the Earth and the height of the object from surface of the Earth. But here is very straightforward. So question already given the distance between center of the Moon to the center of the Earth. So we just substitute to R here. So G is given with this value. Mass of the Earth given already. Mass of the Moon is also given. Okay, so we divide R given by the question square. So remember to square where is stated in the formula. Then you just press your calculator. You'll get the value. So this is how we apply the formula in the question. Okay, so the answer here is very clear, will be B. Okay, then the next question will be paper 2 question from Trial Kelantan 2021, question number 4. Okay, so this is just a part of the question where is related to the learning standard 1 and 2 here. Okay, so diagram 2 show two bodies P and Q of the different masses at a distance R. So the R is given as the value of 175 cm. And you can see the distance is from the center of object P to the center of object Q here. Okay, object Q will be this. Okay, so diagram, okay, already showing it here. So the gravitational force F can be explained by Newton's universal law of gravitation. Okay, where will be with the formula we learned just now already. Okay, so the question number 1 normally will be asked you to give definition for the terms or law. So here will be state Newton's universal law of gravitation. So this is where just now I teach you how to remember. You just remember the formula. So F will be directly proportional to the product of masses of two objects, and then inversely proportional to the square of the distance between the object. Okay, so the answer will be gravitational force between two objects is directly proportional to the product of the masses of the two objects, and inversely proportional to the distance between them will be R here. So this is the simple way for you to remember the definition for Newton's universal law of gravitation. And the formula, this formula will be also listed in the formula list. Okay, so you no need to worry how can you remember the equation here. Okay, then the question B, based on the diagram, calculate the weight P and Q. Okay, so the weight we already learned in the subtopic 2.8, which is the lesson of last week. So we have also only one formula for weight, which is equal to mg. Okay, so the P, the mass given as 8 kg. Okay, and then the G is also standardized using 9.81. So we just substitute to the equation. So WP represent the weight of P, MP represent the mass of P, and G will be 9.81. You just press your calculator, you will get the value as 78.48 Newton. So please remember to give your answer in minimum 2 decimal places and correct unit here, which is Newton. Then the second, the weight of the Q will be using the same formula, W equal to mg, where the m given by the question as 20 kg and the g is given. So we get 196.2. So here we get the exactly 0.2. So you no need to put 2 decimal places also. Consider is correct already. So this is very simple. So 1 mark for the weight of P, 2nd mark for the weight of Q here. Okay, so you can, students, you may share your answer in the chat room. I say you're able to do together with me here. Okay, any question, you also can channel at the chat room. Okay, and then the second question here will be regarding the calculating the force F between object P and object Q here. Okay, so this one will be applying the only one formula we learned just now, F equal to G m1 m2 over r squared will be this. So from the question, so G is given as the value. And just like I mentioned to you, the value G will be normally given in the formula list already with this value 6.67 times 10 power negative 11. And the unit, how we get, I already also explained just now. And then the M1 here referring to the mass of the P, and M2 will be mass of object Q, which is 20 here. Then the distance between them will be 175 cm. Please remember, when we're applying G, G is in SI unit. So you must change your distance in the unit of meter. So it'll be 175 cm to 1.75 meter, right? Divide by 100. So press your calculator, you may get your answer. 3.48 times 10 power negative 9 Newton. Again, 2 decimal places with the correct unit. Okay, so you'll get 2 marks here. First mark will be for substitution. Second mark will be for the answer with correct decimal places and unit. Okay, and then the next question will ask you, are they attracted to each other? Okay, so you can compare the attraction value you get at B2 here is only 3.848 times 10 power negative 9 Newton is very, very small, 0.0000348. And then the weight will be added downward towards the center of the Earth, which is equal to 78.48 Newton for object P. And here will be also same force will be added downward with the value 196.2 Newton. You can see the value is very big difference between the attraction. So the object will be not attracted. So answer will be no. Just like your friend who is always sitting beside you, why your friend is not attracted to you? Although both of us actually have a pair of attraction between each other, but our weight is so big compared to the attraction between your friend. So your friend will be not able to attracted to you, and you will be not attracted to your friend also due to our weight is big enough to overcome the attraction. Okay, so the question will be ask you the reason, which I explained just now. So you have to compare the attraction and the weight. So the answer here, force of gravity added on the respective object is greater. So the force of gravity referring to weight lah. Okay, where you calculate at B1 already here. Okay, it's greater than the force of attraction between P and Q, which is F here. Okay, so I hope that you understand the situation. Okay. Okay, so this is learning standard 3. So that means we already finished the learning standard 1 and 2. So now we go to learning standard 3. Okay, so learning standard 3, you will be learn another new formula. Just now we already highlight the only one formula, which is related to law of universal gravitation, which is F equal to G m1 over m2 over r squared. Okay, so here will be another formula, which is relate the G to G. Okay, so the G, small letter G referring to gravitational acceleration, and then the capital G we learned already, which is equal to the value of 6.67 times 10 power negative 11 Newton meter square per kg square. Okay, so how the formula is formed. So now I want to show you. Okay, so formula to relate G and G. Okay, so will be gravitational acceleration and the constant gravitation. Okay, so here you will be applying two law. So the first law will be Newton's second law of motion, where you learned already at chapter 2. Okay, F equal to ma, and then you converted to F equal to mg at section 2.5 and 2.8. And the new formula you learned just now at learning standard 1, Newton's universal law of gravitation. Okay, so here you can look at the statement regarding the Newton's second law of motion. So it's a gravitational force causes object to fall with G. So the G is with value of 9.81 meter per second square. You learned already at chapter 2. Okay, so as per mentioned just now, the equation is equal to F equal to mg. Where it come from? F equal to ma, you learn in section 2.5. And section 2.8, we already know that the air added to an object towards the center of gravity is G, which is the value of 9.81. Okay, and then the second law here will be the law we learned just now, the gravitational force pull object to the center of Earth. Okay, so with the formula we learned already just now. Okay, so and here these two F is actually same, so will become mg, these parts equal to these parts. Okay, so here the small letter m for the Newton's second law of motion referring to the mass of the object will be apple lah. Okay, and then the m1 and m2 here referring to apple and the Earth. So that means the capital M referring to the Earth mass. And then the M2 will be the mass of the object. Here is the apple here, so it will be small letter m. So you can see both are using the same object, which is apple. Okay, so to make you more easy to imagine. Okay, from here we substitute the value small m and capital M. Then we cancel the value of m, small letter m here. So we get G equal to Gm over R squared. So the formula is come with the application of these two laws. Okay, so from here the G, small g will be the gravitational acceleration, which you know already the value is 9.81 on Earth. Okay, and the capital G you learned also just now. Okay, is the universal gravitational constant with this value. So I highlighted just now with this value already. Okay, and then the capital M will be the mass of the Earth, and small letter r will be distance between center of Earth and the center of the object. Okay, distance between center of Earth or object on surface of Earth, and this formula is only applied with the object on the Earth or above the Earth lah. Okay, with different altitude. Okay, so here the G and M will be fixed value. So G will be this value, and then the mass of the Earth will be also changed. Okay, so that means the G will be only affected with distance, which is r squared here. Okay, so we can come to the relationship where the G, small letter g, will be affected by distance with this relationship. So value g is inversely proportional to the square of the distance from center of Earth for r greater than capital R. So that means is the application where the object is on the Earth or above the Earth. Is not applied at the object inside the Earth. Okay? Okay. So that means the factor that influence value of G will be only distance between the center of Earth and the object. So you can look at the figure here will be the Earth and the satellite. Okay. And you can see from the formula, when the distance increases, so the G value will be decreases. Okay, so you can see the comparison with two different distance of the satellite from the Earth, which is R1 and R2. So the satellite 1 will be more nearer to the center of gravity. Then R2 will be more far apart, more further. So the G will be less at satellite 2 compared to G1. Okay, so this is what we can get from the formula. Okay, so again highlighted, the formula only apply for the object on the surface of the Earth. Okay, so the value of G will be affected by distance as per formula just now we learned. Okay, so that means here the value G will be valid. Okay, it will be valid for different position, will be different now. Okay, so here we have 3. Okay, so for the first will be the object greater than R, greater than radiance of Earth. So which is on the any position above the Earth. Okay, so we'll be applying this formula we derived just now, and the formula again only can apply in 2 cases here, where will be on the surface of the Earth and the object above the surface of Earth. Okay, and not applicable at the object where is inside the Earth. That means under the surface of the Earth lah. Okay, so just now we learned already the relationship. G will be inversely proportional to the square of the distance from the center of Earth at the situation 1, where the altitude is different. Okay, this is the diagram I showed just now. Okay, R1 and R2 with different distance. So when the distance is further, which is R2, so the G will be smaller lah. Okay, so that means the closer the object to the center, maybe it'll be here. Let's say we have 2 satellites, right? 1 and 2. So 2 is further, so the G will be less lah. For the case number 1. Okay, and then the case number 2 will be exactly at surface of the Earth. Okay, so for this case, we apply the formula G equal to Gn over R squared, and we substitute the small letter r as capital R, where represent the radiance of the Earth. Okay, then you substitute the value G, M, and R, the distance between center of Earth to surface of Earth. So you'll get the value where will be exactly the 9.81. Okay, so where will be here. So from this figure, you can see the maximum G will be at the surface of the Earth. Okay, when come to the case number 3, where the R is less than capital R will be inside the Earth. Okay, so the relationship will be different already. So it will be G directly proportional to R. So you can see G is directly proportional to the distance from center when the Earth, from the center of Earth, okay, here will be R less than capital R. So please correction here. Okay, so here we have two positions, R1 and R2. So you can see R1, the point is actually deeper compared to position at R2 here. So the R closer to the center, so will be decreases. All right. So the G will be decreases. Okay. So here you can see R2. R2 is actually greater here, greater than R1. Okay. So the G at position, okay, G at the position R2 is greater than G1. Okay, so that means here, more closer to center of the Earth, the G will be lower. Okay, so you can look at the graph here, these parts. So the G is directly proportional to R at the case where the object is under the surface of the radiance, under surface of the Earth. Okay, so this is three cases you need to differentiate here. Okay, so you can check whether you understand with two questions here. So the first one will be from the Sarawak Trial 2021, question number 8. Okay, so the question will be like this. A radar imaging satellite orbits around the Earth at a height of 500 km. What is the value of G? Gravitational acceleration at the position of the satellite. So question given you radiance of Earth, mass of Earth, and G. Okay, so we apply this formula because all the value is given. G is given with this value.
Nampaknya
N.
ada yang menjawab Cikgu Peh.
Oh,
ada yang
okay.
menjawab A.
Okay, so is it the answer be A? Okay, so thank you for response at chat room. Okay, so let us check together. Okay, so and then the small letter M is given with this. Okay, this one is a capital A, R. So what is the value of small letter R here? With the distance from the surface 500 km. Okay, so here just I explained to you. Okay, so you can imagine it will be like this. The satellite is here. So the R will be radiance of R, capital R here with this value. And the H will be the position on the surface of Earth. So will be 500 km. So that means the R here referring to capital R, radiance of Earth, plus the H, the distance from the surface. Okay, so that means the R will be radiance of Earth, and you have to change your 500 km to meter. Okay, both using meter. So we get the R, small letter R here, will be 6.87 times 10 power 6. Okay, so we just substitute to this formula. G given, M is given. So the distance between Earth and the satellite will be like this. And then you press your calculator. So you'll get answer should be 8.44. AJ is it? AJ, I think. Okay, so should be 8.44. Okay, so you say you not understand yet. Okay, so you can just referring back to my discussion. Okay, so answer here should be D. Okay, so anyway, thank you for your response. Okay, so that I know someone is learned together with me. Okay, and then the next question will be Trial Pahang 2021. We will also question at paper 1. Okay, question number 7. Okay, so this question will be a bit difficult compared to the previous question. Okay, we're using two different G here. Okay, so you can look at the question. So the gravitational acceleration on the surface of the Earth is g. So we know already lah. So the g on the Earth is 9.81 lah. Okay, but here we just need to settle at g. Okay, and then the radiance for the Earth will be capital R. So we know g and r already on the surface of the Earth. So now, what is the distance? Is the acceleration of the Earth changed to 1/4g. So it should be at 2 position. Okay, let's say just now you learned already, you understand already. So at here will be g at position r. So now we want to find where the position will be decreases to 1/4. So g will be here. So if I say here 1/4 should be here, here, and here. So that means at 2 position, where will be higher to surface of Earth and under surface of Earth. 2 position will be given you 1/4g. So we need to find these 2 position. Okay. So just now we know already, when we consider the g inside the Earth or under the surface of Earth, the relationship g to r will be directly proportional. Then for the second case here, when the g at or above the surface, we applying this relationship where g will be inversely proportional to square of the distance. So we'll be at here, here, or here, we do know. Okay, so we're applying these 2 concepts. Okay, so for the case under surface, okay, so we'll get g directly proportional to r. So here will be at the surface. So now we do know the position, we put as R1. But we want to know, we want to get the g become 1/4g here. Okay, so you can see I'm using g for both equation here. So I'm using equation 2 divide equation 1. Okay, equation 2 will be this. Okay, so R1 will be here. 1/4g will be here. Divide R1. Divide equation 1. G will be here. R will be here. Then I cancel out G. Then I move R to here. So I will get R1 is at position 1/4R. Will be these 2. Okay. And then another case will be on the surface, we do know where is the place. So we applying this relationship. Again, we get on Earth will be G with capital R is given by the question with the unknown G and R here already. And then the second case will be, we do know where is the position of R2. Maybe here, maybe everywhere here. So, but we know the G will be 1/4G, which is requested by the question. So the 1/R will become R2 squared. We want to find where, what is the position here. So again, we divide 1 to 2. You can using 2 divide 1 also can, as long as you can solve the mathematics problem here. So 1/R2 divide 1/R2 squared. And this lah, here will be 1, here will be 1. Divide 2. Okay, so divide, you can change lah. Reverse become like this. This is the problem solving of mathematics. It's not related to physics anymore. Okay, make sure this chapter your mathematics skill is no problem. Okay, so and then here we cancel out 1. We cancel out G. Okay, so we move R2 to another side. We get R2, here will be 4R square. Okay, so we move the square to another side, will be square root. We get 2R. Okay, so the answer here will be A. Understand? Okay, if I say you not so clear yet, so I encourage you to watch back my explanation at these parts again. Okay. Okay, so we go to next learning standard 4. Okay, so here, justify the importance of knowing the value of gravitational acceleration on the planet in the solar system. So in this part, okay, so we know already the G value for Earth, so that we can launch any satellite on the surface of the Earth with certain speed. Okay, so by calculation. Okay, so that means the value G is very useful for the exploring the space and also others application. So now we want to know what is the importance to get the G value for other planet in solar system also. Okay, so here importance of knowing the value G. Okay, so here the value of gravitational acceleration G on the surface of others body, planet, moon, or sun, can be calculated by this formula. Okay, if I say you know G is fixed, you can get their distance, and then you can get the G for the at the planet or moon you want to define. Okay, and the value you get is actually can apply at many fields. So for example, okay, so in space exploration, okay, so when we know already the value of G for the certain planet, okay, so we know that when the launching of the rocket on the satellite, we want to reach the planet. Okay, so when the satellite or the rocket reach to the planet, so be attracted with certain value of G. So that means we don't need to use more fuels to reach the place, can be attracted naturally by the planet or the bodies okay, we want to reach. Okay, so that means we can exploring the surface and receive the information of the planet when we able to get the value G and send our space satellite to orbiting the planet, just like the satellite orbiting our Earth, and we get the information we want. Besides that, we also can send our rocket to reach the certain planet. Okay, we want to reach and land safely with the value of G we get. Okay, and then here will be another application, another importance of knowing the G. So will be for surviving of the life. Okay, so here the first will be the development of the satellite. For example, on Earth, okay, we have the satellite of telecommunication and also the satellite for forecasting the weather. Okay, so that we can receive the information across the Earth and transmit it to other place. Okay, so that we can save for maybe natural disaster we already observe on the surface of the Earth. Okay, where we get from the satellite. Okay, and then another one will be research in the field of medicine can be enhanced by obtaining research result from zero or weak gravity. Okay, what means by this sentence? Okay, some of the experiment we want to get, but is actually affected by gravity. Okay, so some of the study we need to have in zero gravity. So it's better we do the research at the space compared to on the Earth. Okay, so that for knowing the value G, we are able to reach anywhere we want to get the info. Okay, so that means the G value is very important for space exploration and also for the survival of life of human here. Okay. Okay, so this is the last part for the Learning Center 4 before we go to break. Okay, so for this one is actually the activity at textbook, page 87, regarding the effect of the gravity on the growth of human. Okay, so here will be have 6 factors will be affected with different condition of gravity. So the first one will be different in density at lower condition and high condition. Okay, so the density we know already the formula. Density equal to mass over volume. Okay, so mass will be always fixed and volume also. So that means with the change of gravity, there is actually no any effect, okay, on changes of gravity here. So that means both will be no change. Then for second, bond fragility. Okay, bond fragility, that means whether the bond will be easy to crack. Okay, the bond of human will be easy to crack if let's say we go to the low gravity condition or high gravity condition here. Okay, so here the weight is equal to mg. So the g lower will cause the weight become lower. So for example, the astronauts, okay, so reach and do the research for a long period at moon, so where the gravity is low, so actually will be affected their bond strength, okay, because the weight decreases will cause, and the gravity decreases will cause the weight of the astronauts, okay, decreases. So when the weight decreases, that means the muscle will be lost, just like doing the gym. If we get greater weight, so we will gain muscle, right? Okay, so if I say we're not lifting for long period, so the muscle will be shrinked. So that means the bone will be also have same problem when faced at the lower wet condition for longer time. So the calcium will be lost, muscle will be lost and become smaller or shrink. So at the low gravity area, so the astronauts will be, the bone become fragile, will be break easily. Okay, and then the high gravity will be not change significantly. Okay, and then the next will be the lung size. Okay, so the lung size here will be, gravity will be directly proportional to the atmospheric pressure. Okay, so with the lower gravity, so the atmospheric pressure will be lower. So when G lower, so that means the atmospheric pressure will be decreases. So the pressure against to our body will be decreases and causes the lungs become bigger, so be increased for low gravity and decreases for the high gravity. Then for the blood circulatory system, okay, so will be related to the weight. So when G decreases, the weight will be decreases. So definitely the blood will be collected upper parts because moving up already with the decreases of the weight. Okay, they will be vice versa for the high gravity. So high gravity will cause G increases, so the weight will be increases. So the blood will be collected at the bottom parts of the body. Okay, so what the problem you can see at the low gravity condition, so when the blood is collected at upper parts, so the facial decimal will be occur. So what is the facial decimal? So facial decimal is actually the swollen appearance at your face because more of the liquid or fluid is already at the upper parts of body. Okay, so this will be causes the eyes vision defects also. And then here will be decreases in the ability to absorb oxygen, slow down the body cardiovascular activity also. Okay, so this will be vice versa for the high gravity condition. When the blood collected at the bottom parts, so the edema will be occur at lower part. So your leg will be swollen, okay, will be reverse way at the low gravity condition here. Then the next, heartbeat rate and the blood pressure. Okay, so the heartbeat rate will be low at the low gravity, high at high gravity condition, and the blood pressure will be low at low gravity condition, high to high gravity condition. Why? So this is because as the gravity decreases for this effect, okay, so the amount of blood will be pumped up decreases, so causes the heartbeat rate decreases and blood pressure will be decreases. This will be vice versa for high gravity also. Okay. Okay, so Cikgu Yani, we can take a break.
Okay, kita akan bagi laluan kepada iklan sebentar saja lagi ya. Dan kita akan berjumpa lagi selepas ni.
Penuh kesungguhan Akademi Youtuber Malaysia Rangka laksana dengan jitu Penuh bermisi Guru AYU yang satu. Permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okey, kita serahkan semula kepada Cikgu Peh KH.
Okay, so
Silakan,
thank you
Cikgu.
thank you kepada Cikgu Ani. Okay, so we continue the learning center 5. Okay, so it's describe the centripetal force in the motion of satellite and planet system. This one will be applying this formula. Okay, I will show you how we get this formula. Okay, so the definition for the centripetal force and centripetal acceleration. So here we have two terms you need to understand. Okay, so the first will be the definition for centripetal force. So it's defined as a force acting on the object moving in a circular path. Okay, you can look at the figure here. So the blue color arrow is the object moving, okay, in circular path with certain speed. We know as a linear speed. Okay, and when the object is moving in circular path, there will be a force added towards the center of the object, of the circle here, of the circle. Okay, so which is towards the center of the circle. You can look at the GIF here. So this figure. Okay, and the direction is towards the center of the circle with this. Then the centripetal acceleration is actually the acceleration experienced by the object which is moving in the circular path and also directed towards the center of circle here. So you can look at the GIF. The object is moving with certain speed, we know as linear speed with blue color, and F and R will be towards the center of circle. So the F is the centripetal force, which is added to the body, will be the blue color dot here. Okay, and the force will be towards the center of gravity. And the object will be also experience the acceleration, which is also directed towards the center of circle here. So it's also at the same position. So that's why you can see the F with red color and A at the pink color, both will be at the same direction towards the center of circle. Okay, so swinging an object on the string requires string tension. You can look at this figure. Okay, so the string tension will be here. So it'll be towards the center of the circle also here. Okay, to provide the centripetal force to hold the object in the circular motion. So that means the centripetal force is actually equal to the string tension, which is needed to make the object moving in circular motion. Okay, so when we cut the line, the string, so the object will be moving in straight line, in straight motion, and no more in circular path. Okay, so you can see if the string is released, the object will continue move in straight line, tangentially to the object. So initially the object is always moving tangent to the force. So when we cut the string, so the object will be moving in straight line, which is tangent to the circle. Okay, which is tangent to the circle. Okay, so the formula for centripetal force will be F equal to mv squared over r. So m referring to the mass of the object. Okay, then v will be the linear speed, which is always tangent to the circle. The circle is here, tangent to the force here. Okay, we know as linear speed lah. Then the radians will be r. So the factor affecting the centripetal force will be 3, mv and r. Okay, so mass will be directly proportional. When m increases, centripetal force will be increases. Linear speed will be increases the centripetal force also. Okay. Okay, then the third one will be, you can see the centripetal force is inversely proportional to R. So when the R decreases, or here the R increases, so the F will be decreases. Okay, so here will be the formula of the centripetal acceleration. So again, you can look at the GIF. The F will be, F and A will be towards, directed towards the center of circle, with the object moving with linear speed v. Okay, so the formula derived from the force formula and the centripetal force formula, which is mv squared over r. Okay, so both of the F will be equal, so we get these terms here. Okay, ma equal to mv squared over r. Then we cancel m, we get a equal to v squared over r. So another formula you need to memorize. Okay. A will be centripetal acceleration, m will be mass of the object, v will be linear speed, which is blue color, v here, and then the radiance will be here to center. Okay, so situation of applying the centripetal force, you can look at the GIF here. We have three situations I'm going to discuss, which is the tension, okay, friction, and also the gravitational force. So first one, you can see when driving on curve, just like the figure. Okay, so as the car moving along the curve, the frictional force adding upon the tire. So you can look at the GIF also. Okay, so the tire of the car provides the centripetal force required for the circular motion. So that means the frictional force here will be equal to the centripetal force. The second will be Earth orbiting the Sun. Okay, so as the Earth orbits the Sun, gravitational force is acting upon the Moon, providing the centripetal force required for circular motion. So just now, the frictional force applied to the tire of car, which is needed to produce the centripetal force so that the car can be moving in circular motion. The second case will be gravitational force causes the centripetal force provided to, here will be actually Earth. Okay, Earth. So acting upon the Earth provide the centripetal force required for circular motion. Then the third will be ball rotating to a rope. Okay, so here, so when the ball is tied a rope and is rotated, the tension of the rope is responsible for ensuring the ball remain in circular motion. Therefore, tension of the rope is a centripetal force. Okay, so just now we define already the centripetal force is a force causes or required by an object to move in circular motion. So in first case, the frictional force is the force that able to provide the centripetal force for car to moving in circular motion. The second case will be the gravitational force. Gravitational force providing to Earth so that the Earth able to revolve in circular motion. Then the third case will be the tension of the rope is needed for providing to the ball here so that the ball able to move in circular motion. Okay. So to understand the centripetal force using centripetal force kits, okay, so this one will be the activity at page 89. Okay, so you can see this is the apparatus listed, okay, we have rubber stopper, thick string, plastic tube, crocodile clip, slotted weight here. Okay, so here initially the radius set as 50 cm, and the mass started with 100 gram here with holder. Okay, so step 1, the stopper is rotate above your head. Okay, so you have to rotate your head at a certain speed until you're able to rotating horizontally, just like the figure diagram number 2 here. So the crocodile clip is remain 1 cm above the glass tube. So the distance here to here, very small parts here, should be always 1 cm. Why they want to maintain 1 cm? Because in this condition where the position here 1 cm and no change is at a condition where T will be equal to weight will be mg. So the tension represent centripetal force, right? Just now we mentioned already at case number 3. So at this condition where the position 1 cm is always there, so the centripetal force will be equal to tension, will be equal to weight. Okay, so release the slot weight and continue rotating. So when you release this one, okay, so you will be rotate at certain speed, right? You observe your speed. Okay, so here the tips just I mentioned to you already. So the centripetal force with this formula, mv squared over r. And here we have the weight already, W equal to mg. The capital M will be mass of the slotted weight. Small m will be the weight of the stopper. So here tension will be equal to W equal to Fc, just like I mentioned to you already, when the position 1 cm is always there. Okay, so repeat the step 1 to 3 with the total mass of 200 grams. So we add on another weight. So when the mass increases, so W increases, so that means the tension will be increases. So when tension increases, so that means the centripetal force will be increases. So what will be changed with this formula? So V will be increases. So you'll be rotating with higher speed to maintain the position where here will be 1 cm also. Okay, because the W and T is the same, the position will be same. When here will become greater than 1 cm, so that means the weight increases already, tension will be lower already, and vice versa also. So that means for this experiment, you must fix your 1 cm here, so that the T will be equal to W, will be equal to centripetal force. Okay, so comparing the speed, so we expected when weight added already, the speed will be increases with this formula. Okay, weight increases will be cos, T increases with cos, C increases. So V will be increases with R is fixed, which is 50 cm stated in step 1 already. Okay, and then you repeat step 4. Okay, but now what is the changes here? When the stopper is rotating, pull the lower end of the string downward, so that the rubber stopper rotate with decreasing radius. Okay, so in step number 5, so we pull down this part. So now rotating with smaller circle already. So that means the R decreases. So when R decreases, Fc will be increased, centripetal force. So centripetal force will be equal to tension. So now you have to feel how the tension in the string added to your hand already. So you can feel that the tension become higher caused by the radius decreases with the formula. Okay, so that means the T will be increases when the R is decreases. Okay, so we look at the discussion at your textbook, page number 78. Did I say I'm not mistaken just now? Okay, so when the rubber stopper make a circular motion, the straightened string exerts the force on the rubber stopper. What is the direction of the force? Okay, so what is the direction of the force? Okay, so here the direction, here the force will be centripetal force, but the direction it will be towards the center of circle here lah. So it should be this okay. Unless the question asks what is the type of force, will be centripetal force lah. If I say direction will be towards the center of circle. Then second, what is the relationship between the speed and the centripetal force? So just now I mentioned we're using this formula. So when speed increases, force will be increases. Okay, Fc increases, V will be increases. Then next will be how does the centripetal force Fc change when the stopper make a circular motion with smaller radians? Will be step 5. When R decreases, Fc will be increases. So you can feel the tension is getting greater lah. So here will be R decreases, Fc increases. Okay. Okay, so we go to the checkpoint question number 5. Okay, it's a real SPM question 2021, question number 3 at paper 2. Okay, so diagram show the rubber stopper of mass 0.2 kg is tightened to one end with the nylon thread and hang to a load on the other end. Will be like this now. This is a stopper. This will be the weight. So the rubber stopper is spin in the circular path at the constant speed. So the V is constant. Okay, so the first question, name the force that remain the rubber stopper in circular path. Just now I mentioned to you, we explained already. So we want some of the object moving in circular motion, they need have the centripetal force. Okay, can be in friction at case number 1, gravitational force at case number 2, and tension for case number 3. If I say just now you understand the example I explained just now, we in our daily life we actually have many others example of the application of the centripetal force now. Okay, you can search more at the internet actually. Okay, then mark the direction of the force. So the force will be directed towards the center of circle. So you have to draw at the diagram provided. So the F here, you must showing the arrow. Okay, it's more easier way will be at the track provided in the figure, then label as F. If I say you not draw the line, the arrow at the track, so you must draw the path from the track to center of circle here. If I say you draw an arrow but not from the circle to the center, mark will be deducted. Or you draw without arrow will be also wrong. Okay, must draw at number 1 and number 2 I teach you just now. Then number 3, draw the arrow to show the direction of the speed. Okay, so the speed will be tangent to circle, right? Just like I mentioned to you. Okay, at position M, M will be here. So we have to draw the arrow at M. So be this label with V. And next question, the rubber stopper is spin with linear speed with the value 10. Calculate the F at D on the rubber stopper when the radius is 1.5 meter. So F you need to calculate. So we need to give calculation. So we need to substitute the value in the correct equation. So we encourage students to write the equation because sometimes the mark will be given for equation. Okay, so from the question just now, the mass will be 0.2. So here will be 0.2. And then question given V, 10. R will be 1.5. This question very easy. We just substitute, you get first mark. Press calculator, give answer in 2 decimal places minimum and correct unit. You get second mark. Okay, so reject with the answer with 1 decimal place or without unit. Okay, so see what will happen to the radius of the circular path when the rubber stopper is spin with higher speed. Okay, so this one actually we discussed in the activity already just now. So what's the happen to radians when the speed is increases? Okay, so here we apply formula. So here the formula is provided at formula list lah. We apply this formula. So when the V, so when V increases, R will be increases. So that means when you spin with higher speed, the radians will be increases. So be 1 mark here. Okay, so we go to last learning standard 6. Determine the mass of the Earth and the Sun using Newton universal law of gravitation and centripetal force. Okay, so here another formula you need to know. You need to know how to derive here lah. Okay, but normally the how to get the formula is not tested lah. We just apply the formula. Okay, okay. So the formula, how we get the mass of the Earth and the Sun is get from here lah. So to derive the mass of the Earth, M formula and G formula using this M formula actually. M formula will be the formula for mass lah. So we get from this method. No G using only. So here the Earth with the distance R to Moon. Then the Moon, the mass will be small letter m. Earth will be capital M, moving with linear speed. The Moon linear speed will be small letter v. Then R will be the orbital radiance. Okay, and then T will be period of the Moon around the Earth, will be about 27, 1/3 days, right? Almost 1 month lah. Okay. Okay, so firstly, you need to get the distance traveled by the Moon in one complete circuit. Okay, so here, distance for Moon revolve the Earth will be 1 circle. So hot tips here, you need to know the formula to get circumference for circle lah. So you learn already at PT3, which is 2 pi r. And linear speed here, speed, the formula will be distance over time taken. Okay. Okay, so that means the distance traveled by Moon for 1 complete cycle will be equal to 2 pi r, which is the circumference of circle. And the speed we apply, formula distance over time. So the distance will be 2 pi r. Then time taken will be period where the Moon taken to complete 1 cycle will be using capital T. So that means we get this formula. Okay, then we apply 2 laws here again. First will be Newton universal law of gravitation. Another one will be centripetal force. So these 2 F will be equal. So again, we substitute, we cancel N and R. So we get Gm equal, G over R equal V squared. So V we get already at here. We substitute to this V. Okay, so we replace V to 2 pi R over T. So we get this. Then we rearrange, we'll get the formula we want. Okay, so this is the formula of mass of Earth or the Sun. With the value substitution, you will get the mass of the Earth and mass of the Sun. Okay, but this formula is not only used for get the mass of the Earth. Okay, so here we have the last question to discuss the application of the formula just now we learned. With the trial question of Negeri Sembilan 2021, question number 8, paper 1. So diagram show a satellite orbiting the Earth at height 600, so be h here. Calculate the linear velocity of the satellite. So we want to get V. Okay, so the capital R is given, radius of the Earth, mass of the Earth is given, and G is given. So how we get linear speed? Here we need to apply 2 formula. Okay, so here linear speed is given. Okay, so we need to apply V equal to 2 pi R over T. So to get T, we need to use the formula mass of Earth we learned just now. So we want to get T. Okay, so the R will be distance center to satellite. So be radius of Earth plus the distance surface of Earth to satellite, which is 600 km. Okay, so given by the question, so we need to get small letter r, distance center of Earth to satellite. So remember, change the 600 km to meter. So we get small letter r will be 6.97 times 10 power 6m. Okay, so the formula, this formula is come from here. I rearrange already, so become this. Then you just substitute the given value. This one will be small letter r. This one will be g. This will be mass of Earth. So press the calculator, you get this value s will be second because we're using unit SI. So this will be period. Then we substitute to this formula. R with this value. T with value we just get at here. So press calculator, you get this value. 7,558.5. So the closest will be C lah. So this is the where we apply this formula. Okay, due to time constraint, okay, so you can get more question in the discussion I did at the Teknik Menjawab during the SPM period. This is early of this year lah. Okay, so later on the Cikgu Yani can share the link to get this discussion. Okay, so that's all for my sharing today. Okay, thank you everyone.
Okay, saya postkan link tu dulu.
So saya nampak satu pelajar yang lama saya ajar, Teo Yong Yu. Okay, so this is a student I teach at my previous school. Okay, so compared to these students lah, he actually get 4 flat in his STPM result. Okay, congrats Yong Yu. Okay, thank you for supporting me again. Okay, I'm teaching the students during my SPM time, 2021, if I'm not mistaken. Okay, so and I see him again at my college tingkatan 6. Okay, he's a very hardworking student. So, okay, so congrats Yong Yu, and thank you for supporting me.
Ya, dia support kita hari ni. Okay, sekejap ya. Saya akan postkan sekali link sijil.
Okay, so the previous video you can get more question regarding this topic lah. Okay, so thank you for sharing the link.
Okay, terima kasih kepada Mr.Peh KH atas perkongsian yang sangat padat dengan info yang menarik tadi. Okay, tahniah diucapkan kepada semua yang setia bersama kelas pada kali ini dari awal hingga ke saat ini ya. Okay, link sijil sudah dimasukkan di bahagian chat bersama link latihan dan nota daripada Mr.Peh dan link sijil akan tamat dalam tempoh setengah jam selepas live ini. Pastikan anda menggunakan email edited semasa mengisi borang sijil lah. Okey, kelas seterusnya untuk subjek fizik adalah pada hari dan waktu yang sama pada minggu hadapan. Tolong sampaikan kepada rakan-rakan semua ya. Sila layari www.akademiyoutuber.com untuk dapatkan info terkini dan jadual kelas tuition percuma ini. Jom kongsikan portal AYU ini kepada rakan-rakan dan guru-guru seluruh Malaysia. Juga diingatkan semua kelas online percuma ini boleh ditonton semula melalui link yang disediakan di portal AYU. Okey, presenter, kita dah rekod tu. Okey, semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Ingat hashtag bermula percuma, selamanya percuma, insyaAllah. Cikgu Peh, kita ada penggulungan tak?
Okay, so saya rasa topik ini sebenarnya sangat panjang lah. Dan saya sebenarnya ada banyak soalan nak share supaya kamu lebih faham lah. Okay, so tapi masa sebenarnya tak mencukupi lah. Okay, so you boleh lah tengok lagi lebih banyak soalan daripada link yang Cikgu Yani sudah share. So terima kasih lah untuk semua yang sentiasa support kami. Okay, so thank you Yani.
Ya, Cikgu Peh, ada link juga diletak di bahagian description kan?
Ya,
Okey, ada ya. Okey, yang baik datangnya daripada Allah dan sebarang kekurangan datang daripada kelemahan kami sendiri. Bunga dedap di atas para anak dusun pasang pelita. Andai tersilap, tutur bicara, jari disusun, maaf dipinta. Sekian, terima kasih. Jumpa lagi di minggu hadapan. Assalamualaikum, bye-bye.